OSPF stands for how EIGRP uses RTP. Okay, good question. Just think like this is R1 and this is R2. There is a phenomenon in EIGRP that whenever this guy will send a update, this guy will send a acknowledgement. This whole process is defined by RTP. You want to see? Okay. I think you are very much clear with the addressing scheme I am using. So there is no need to write every time that which network I am using. Fine. Network 0.0.0.0 will enable EIGRP on each and every interface of router. Fine. Each and every active interface of router. Fine. I got the adjacency. See. See here, update is generated. Agree? This thing is clear? Now, I am stopping the capture. This is the update packet. You can see here, sources, destination is 224.0.0.10, a multicast address. For this update, R2 is giving a acknowledgement. This whole process is defined by RTP. This thing is clear. Now, what is the information in the update packet if you want to see? Sorry. First of all, protocol number used by EIGRP is 88. This thing is fine. Now, you can see here, IP internal root is 1.1.1./32, and these are the metric components associated with the root. This thing is clear, and this value is called hop count, which is also forwarded with the root. We discussed it. Fine. What are the things that are forwarded with the root? Yes. Metric, K values, hop count, each and everything. This thing is fine. Prefix, prefix length. Everything is forwarded in the root. This thing is clear. Now this is the acknowledgement. You can see here, you can notice one thing here, acknowledgement is unicast. Acknowledgement is unicast. This thing is clear. This is my acknowledgement. And you know, acknowledgement is nothing, acknowledgement packet is nothing but a similar packet, or you can say a hello packet. Acknowledgement is similar to hello packet. Only the difference is in the opcode. Fine. In the case of hello, it is hello. In the case of acknowledgement, it is acknowledgement. All other things are same. But in the original hello message, we have some other contents also, like hold time, hello, sorry, AS number, K values. But in the acknowledgement message, there is nothing like this. So acknowledgement is just like hello message with no contents of hello message. Fine. Now guys, there is a question for all of you. If R1 is sending the update, R2 is receiving an update, but R2 is not able to reply. R2 is, so what R1 will do? Will R1 send the update again? What do you think? This process is also defined by RTP. RTP defines the whole process of exchange of updates. Question is clear? If R1 is sending the update and R2 is not able to reply, what will happen? After how much time? Is it necessary? You don't know about access list. All of you don't know anything about? Okay. If I have to do this practical, I have to use access list. Why I have to use access list? To block my reply. To block my reply. So I don't think so at this stage there is a need to show you the practical. But try to understand a thing. If R1 is sending an update and R2 is not able to reply, after sending one multicast update, R1 will never send again multicast update. R1 will always send a unicast update. For 16 times or not, I don't know that thing. It's written in the book, but we have not discussed that thing. Fine. The thing is, if R1 is not able to get a reply for update, next time R1 will not send a multicast update. It will always send a unicast update. How many times? We will see to it. Fine. RTP is defining a process, nothing else. The way you are thinking is wrong. What he is saying, RTP is just defining a process, that for these messages we need acknowledgement and for these messages we don't need acknowledgement. Just think like, for hello I need acknowledgement. No, because it is a periodic message. For acknowledgement message itself, I never need acknowledgement. But for update message I need, for query I need, for query acknowledgement is reply. So RTP is defining a process for which messages you need acknowledgement or for which messages you don't need acknowledgement. You don't have any information about ACL. So how you understand this case that R1 is blocking the reply? You don't know that how I have blocked the reply, and these things you will never try at your place. Just read your book, do the practicals. This is just a thing I am showing it to you. What is the behavior of EIGRP as he has asked the question regarding RTP. Fine. Okay guys, again I will generate a update, but before generating a update, let me start the capture again. Start Vaisha. Hellos are sent. You can see here. You want to see the content in the original hello message? Guys, you are studying EIGRP at your place. Only then these things will be helpful. Otherwise, these things will be like boring. This is the actual content in the hello message, EIGRP parameters. You can see K1, K3, whole time, my AS number. Fine. See, hello and ACK are the same messages, but with a different opcode. Fine. Now see here, R1 will again generate a update. IP address. Fine. This thing is clear. It is sending the reply, but it is not getting the after 16 unicast messages. What it will do? But it is not stopping. Okay, wait. Let's go up. Now see. First of all, update was multicast. He tries to give the acknowledgement, but acknowledgement was not accepted by R1 as I have blocked the traffic. Again he is sending the update, but this time update is unicast. But R1 is not able to receive the update. This thing is fine. You can see here, always update is sent unicast. You can see here, never again multicast. Again unicast. And routers will keep on exchanging the update. So guys, in which case that 16 unicast message thing will be used? Yes. Where you read that thing? Where? Which page? You have to tell me, we have to discuss it. In this case, it will keep on sending the unicast update until he will get a reply. You can see here he was keep on sending. It has never stopped after 16 updates. Fine. So for which case? No IP access list extended 101. You can see here they are exchanging hellos. Everything is going fine. In this case also there is no update. I think that will be a scenario in which there will be 16 unicast messages. For which message you have read that update? बताओ यार, किस मैसेज के लिए पढ़ा था? पेज नंबर 790. हाँ भाई, कहाँ पढ़ा? Read the line carefully, yaar. Well, when EIGRP sends multicast traffic, it uses the class D address. Each EIGRP router knows who its neighbor are. For each multicast it sends out, a list is built and maintained that includes all neighbor who have. If a router doesn't get a reply from a neighbor via the EIGRP will then try using unicast to resend the. If there are no replies from the neighbor after 16 unicast attempt, the neighbor will be declared dead. This process is often referred to as reliable multicast. Guys, this is just for hellos. This is just for, not for the update. If I am sending an update and my neighbor is not replying me for that update, I will never mark my update neighbor as dead. This thing is clear. Router keep track of the information they send by assigning a sequence number to each packet that enables them to identify old. You are getting this point? That whenever I will send a multicast message, I will add a sequence number to it, just to make the other router know that this is a new packet, this is not a old packet. Redundant information and data that's out of sequence. You will get to actually see this information in the neighbor table coming up when we get into configuring EIGRP. This thing is clear. So now we can start with OSPF. OSPF stands for Open Shortest Path First. First of all, it is a link state routing protocol. Its behavior is classless. There is nothing like auto summarization. Fine. Next point about OSPF. It works on an algorithm called SPF, shortest path first. To calculate the shortest path, it uses a metric. Metric is called cost. This thing is fine. Now, how router will calculate the metric? Metric is totally dependent on bandwidth of link. Metric is totally dependent on bandwidth of link. Now, whenever a router has to calculate a metric, router will use the formula metric, or you can say cost is equal to 10 to power 8 upon bandwidth of link. What is this 10 to power 8? 10 to power 8 is called reference bandwidth. What we call it? Reference bandwidth. That I am calculating my cost in reference to this bandwidth. मैं अपने लिंक की मैट्रिक कैलकुलेट कर रहा हूँ, कॉस्ट कैलकुलेट कर रहा हूँ, लेकिन रेफरेंस में मैं क्या वैल्यू रख रहा हूँ? 10 टू पावर 8. जैसे आपके पेरेंट्स किसी और के बच्चों को रेफरेंस में रख के आपका फ्यूचर सोचते हैं कि हमारा बेटा भी एक दिन ऐसा बनेगा. They are not referencing you, they are referencing someone else to calculate your future. In the same way, OSPF is calculating metric. OSPF has chosen a value called 10 to power 8, or you can say it as 100 Mbps. Now, what will be the cost of a link that is 1 Gbps? It will be 100 Mbps upon 1 Gbps. It means how many Mbps? 1000. And cost can never be less than 1. It's not possible. So in this case, you have to change reference bandwidth. What I am trying to say, if in your topology you are using links whose bandwidth is more than 100 Mbps, in that case what you have to do is you have to change reference bandwidth. Otherwise, for 100 Mbps also and for 1 Gbps also, cost will be 1, because OSPF can never calculate cost less than 1. This thing is clear? Okay. Next thing. OSPF use multicast address 224.0.0.5 and .6. Two multicast addresses. Why they are used, we will discuss. 225.0.0.5 is the normal multicast address. Normal. Like every routing protocol is having, RIP version 2 is having, and EIGRP is also having. Fine. In a similar way, OSPF is having. Why we use 6, we will discuss it. Fine. For OSPF also, maximum paths are by default 4. Next thing, AD for OSPF is 110. Fine. Next thing, OSPF is a layer 3 protocol. It uses protocol number 89. OSPF packets are also encapsulated with IP. You can see here, hello. This is IP packet. This is IP packet. This is EIGRP packet. It means EIGRP packets are encapsulated with IP packets. In the same way, OSPF packets are also encapsulated with IP packets. Clear? This thing is clear. Next thing. OSPF also perform equal cost load balancing. What do you mean by equal cost load balancing? If I have two paths for a single destination and cost is same, router will install two paths in the routing table. But for if two paths cost is not same, path with the lowest cost is installed in the routing table. These things are fine. Any problem with these things? Now, OSPF will also maintain three tables. First is called enable table. In EIGRP we have topology table, but in OSPF we have database table. Third table is routing table. Guys, all of you know EIGRP is a DVRP protocol. Works like DVRP. DVRP stands for distance vector routing. That's why in case of EIGRP we have a concept of routing by humors. It means R1 is having all the database, but R1 only knows R2. R1 never knows R3 or R4. This thing is clear. But in case of OSPF, first thing, every router will have its own database. Every router will have its every router will share its database with all other routers in the same domain. In the same, read the line again. Every router will share its database with all other routers in the same. This thing is fine. Any issue to anybody? Now, guys, every router is creating its own. How they represent it? How they represent it? Every router represent its database with a unique ID. With a unique ID. Like you are representing yourself. What is your name? Shubham. Full name. He is representing himself by his name. Shubham Verma. You are representing yourself by your name. You are representing yourself by your name. You are representing yourself by your name. In the same way, a router is representing its database by a unique ID. By a unique ID. That ID is called router ID. Okay guys, we are sitting in the same class. We belong to the same domain. If my name is Piyush Kataria, his name is also Piyush Kataria. And one thing, I have to share my database with all of you. He has to share his database with all of you. So there will be a problem. You will never get to know who is the real Piyush Kataria. So what I am trying to say, in the domain, every router must have unique router ID. Second thing. What is the second thing? if two routers have same router ID, they cannot share database because their database is represented by same ID. This thing is clear? Fine. Concept is clear. Why we need router ID? Router ID is used to represent the database. Two routers with same router ID can never share database. If he is in the middle and we two are the routers, you are understanding the case now. R1, R2, R3. We two have same router ID. He will install database of one of us, not two of us. This thing is clear? At a single instant of time, he will only install database of one of us because our name is same. This thing is clear? Yes? We will discuss it in the practical, what it will do. It is just a phenomenon to understand. Yes, it will create flapping of updates. This thing is clear? Now, yes. Bro, I am just taking an example. Like if two routers have same ID, like if two of us we have same name. So there is a problem for you to understand who is real. Piyush Kataria, same problem is with the routers also. If two of its router in the same domain have same router ID, how he will able to understand which is the real one? This thing is clear? The same problem I was discussing. Now, next question is how router will elect router ID. Yes or no? This will be the question in your mind. Just think guys, this is a router. First preference will be given to manually defined router ID. If this is a router and you have defined router ID manually, it will choose the manually defined. But I have not configured manually the router ID. Second preference will be given to highest loopback address. Just think like I am having two loopbacks, 1.1.1.1, 2.2.2.2. So which will become router ID? 2.2.2.2. Why? Okay. If I have not defined loopbacks also, then preference will be given to read the third point. It means the interface which is down can never become router ID. Can never become? Guys, you people don't think. I think so. You have to ask a question, sir. This interface is now up. Its IP is 192.168.1.1. This interface is 12.0.0.1. Which interface will become router ID? Agree? Now what I said, I shut down this interface. Router will again select router ID or not? What do you think? अभी आपका नहीं मेरा क्वेश्चन है. Fine. Now this is my question. You will look for the answer. भाई सोचो, बैठे मत रहो. Why I am explaining the concept step by step, that you people think about the cases. So think and ask. So what will happen when we do this? Fine. So look for the answer. If on a router We have two interfaces and highest interface is elected as the router ID. If that interface goes down, do router will change its router ID or not? You have to look for the answer. Fine. From next time asked questions like this. Fine. Now, as you enable OSPF on a router, with what command you will enable? Router OSPF command. Agree? First work router will do is electing. It means as soon as OSPF comes up on a router, first thing is done. That is elected. Now again a question. Yes, very good question. That if no interface is upon the router, no IP address is assigned on the router, what router ID will be elected? 0.0.0.0. And as soon as an interface will come up, that IP will be elected as router ID. ऐसा कभी नहीं होगा. ऐसा कभी, because there is a thing, router ID is elected only once. When OSPF starts on a router, router ID elected only once. मैंने दिया ना यार, अब तुमने पूछा तो नहीं ना क्वेश्चन, फिर भाई एक तो आंसर दिया यार, चलो घर जाके देखना ना पड़े, अब तो मुझे ही कह रहा है यार. Router ID elected only once. It will not change until you define it manually. Until you define it. What I am saying, on a router, let's say I assign an IP address to the interface as 12.0.0.1. Router ID will be 12.0.0.1. I want to change it. I cannot change it by assigning a highest loopback address this time. No, I have to assign it manually. This thing is clear? Now, second thing about router ID, and most of the people are very much confused with this point. So, listen to me carefully. Router ID can be an existing IP address related to the interface, or can be a fake IP address also. Can be a existing IP address on the interface, or can be a fake IP address also. What I am trying to say, this is a router. Fine. Loopback address is 1.1.1.1. So this will be elected as router ID. This loopback is 2.2.2.2. This interface IP is 12.0.0.1. This interface IP is 13.0.0.1. Fine. But I want to assign router ID for this router as 192.168.1.1. I can do this thing also. But in this case, you cannot ping your router ID. You cannot ping your, but in this case, you can ping your router ID. This thing is clear? So it can be an existing IP address and it cannot be a existing IP address. It's your choice. Okay. One information. Router ID can be a name also. It is also possible, but it is not in your syllabus. Fine. This thing is clear? Yes.
Sir, host name जो हम host name देते हैं, वो क्या होता है? Router ID नहीं देते हैं.
होस्ट नेम किसका भाई? यार वो राउटर का नाम होता है. That is the name of the router. What is router ID here? Router ID is used to represent database of OSPF on the router. Now guys, question can be this also. Why EIGRP was not using the router ID? In case of EIGRP also, we have the concept of router ID. Yes, router ID is also elected in EIGRP, but it is not used. Why? Because EIGRP is a distance vector routing protocol. For every information that relates to my topology, I am dependent on my neighbor. I am dependent on the next hop. This thing is clear. So there is no use of router ID. This thing is clear. Host name is used to represent the router. Next thing, in case of OSPF, there is nothing like AS. There is nothing like AS. Fine. But we have something called process ID. Please add a keyword here. आपके घर पे नाम क्या है? Your nickname or your home name is just restricted to the house. People outside your house never call you by that name. In the similar case, process ID of OSPF process is limited to the router. Whenever router will send any kind of message, any kind of multicast message, it will never include its process ID in that message. This thing is clear? Fine. It means on two routers, I can run the same process number also and I can run different process numbers also, because OSPF process ID will remain locally significant to the router. What is the use? I am enabling a process, so I have to give it a name or number. Number is the option present. Number is the option present. See, if this option is not present, you can enable only one OSPF process on a router. If this number is not present, you can enable only. If there is a need that you have to enable two OSPF process, then what you will do? How you will differentiate them? You can differentiate them using a number. EIGRP process का क्या use था? What was the use of EIGRP process? That can be a design requirement, that you are running multiple processes on a router. It is similar to a EIGRP process you were running on the router. A dynamic routing protocol process, you can say, that is used for routing. I cannot make you understand that thing, that what is the need of, why we have to need two, why we have to run two different OSPF processes on a router, but we can. If this number is not there, you cannot run two processes. So number is there so that you can differentiate between the processes if you are running more than one. Yes. We will run a single process, because to define the domain, everything depends on the domain. If you remember, in case of EIGRP, between two routers, what thing was specifying the domain? AS. So we have something like AS in OSPF also. We will discuss it. What I am trying to say, there is nothing like AS. There is process ID, which was not present in. And if you want to know the truth is EIGRP uses its own AS number as a process ID. You can enable multiple EIGRP processes or multiple EIGRP AS on a single router. What I am trying to say, like this is R2, this is R3, this is R1. You want these two routers be a part of AS100? Yes, it's possible. If you want these two routers be a part of AS200, this is also possible. What you will do? You know the configuration of this router, you know the configuration of. What about the configuration of this router? Router EIGRP 100. You will advertise network A. Exit. After that you will write router EIGRP network. But there is a rule. These two processes by default will not communicate. Similar case with OSPF also. Here you can run. No, OSPF is different, like this. On this interface you can run process 1, on this interface you can run process 2, but they will never communicate. This thing is clear? And to define a domain in case of OSPF, we have a concept of area. What is area? It is used to define domain. There are two types of areas. One is backbone area, other one is normal area. What is backbone area? Area 0 is called backbone area, and other than area 0, all others are areas are called normal areas. Other than area 0, all areas are called normal areas. Which area is called backbone area? Area 0. First thing that we have to understand is how communication occurs in a single area. That area can be any area. That area can be backbone area also, or it can be a normal area also. This thing is clear. So today we have to discuss this topic, how communication will occur in a single area. This thing is fine. We will start with this. We will see. If we have time, we will discuss how communication will occur in two different areas also.
तीन राउटर है हमारे पास. बीच वाले राउटर पे एक साइड OSPF और ये जेट पे एक साइड OSPF है, और हमको कम्युनिकेट ये जेट OSPF में नहीं कराना. ये जेट टू अदर मींस एक साइड का ये जेट है, तो वो बीच वाले राउटर पे हमको राउटर ये जेट पे राउटर OSPF दोनों चला.
बिल्कुल.
इसको दिक्कत तो नहीं है.
No. It means you can run two different routing protocols on a single router also. Fine. There will be no issues. Fine. मैंने डोमेन को डिफाइन करना बताया. मैंने AS की तरह बोला कि we have something called area like AS, but I have not discussed area till now. See, in case of EIGRP, if you want to compare, if you want to understand, you can understand it now. In case of EIGRP, I am defining AS in the beginning. It means every network I will define under it will belong to same AS, agree or not? But in case of OSPF, I can define a process ID and I can map multiple domains to the same process ID. So there is no need of multiple processes. So what I will do in real time, I will run only a single process, process number 10. I will mark this in area 41, this in area 0. I can define these two different domains under a same process, but in case of EIGRP it's not possible. Now, to make communication possible between two routers, first things that comes in my mind is neighborship. Fine. How two routers will become neighbors? This thing is clear. So I will take example R1, R2. I will write here router OSPF 1. 1 is the process ID. I will define a network A. After that it's wildcard mask. Wildcard mask is compulsory in case of OSPF. After that, to which area I want to assign this interface? I want to assign this interface to area 10. Area 10. This thing is clear. Now I will come on R2, router OSPF. Let's say process number is 2. I will write here network A, wildcard mask, area 10. Area 10. What will happen after defining this network command? Two things. Like they were happening in EIGRP. First thing, router will start sending hellos, multicast hellos on this particular interface. At what address? 5. And router will include this network in the database. This thing is clear. Now, in case of OSPF, before sharing the database, first of all, two routers will become neighbors. After becoming neighbors, they will check some conditions. If those conditions were matched, then only they will exchange database. Otherwise, not. See, what is the difference in case of EIGRP? As soon as two routers become neighbors, they will exchange database. It means if I am saying two routers are neighbors, it means they have exchanged the database. But in case of OSPF, if two routers are neighbor, it doesn't mean they have exchanged. There can be a chance they have exchanged and there can be a chance they haven't exchanged. This thing is clear. Now, how they will exchange database, that will be a second part. First part is how they will become neighbors. So, to differentiate between these two things, I have some neighbor states. What are those neighbor states? First one is yes. How many neighbor states are there? Now, what is down state? Down means I have defined a network command for this interface, but this interface is shut down. This interface is shut. What I am trying to say, OSPF is enabled on the interface, but interface is shut down. So OSPF state will be down. This thing is clear. Second thing, init. What is init state? It's visible. R1, R2. As you define the network command on both of the router, R1 will send a, R2 will also send a hello. Now guys, see here. When R2 will receive a hello from R1, there can be two cases. First is R2 is receiving hello from a R2 is receiving hello from a or R2 is receiving hello from a. Agree? There can never be a third case. There can never be a third case. In EIGRP also we were having the same cases. When a router heard about a hello, there can be two cases. One is it is getting hello from a, second is new neighbor. If it is getting hello from an existing neighbor, what it will do? हाँ भाई EIGRP में बताई दी ये बात. क्या करता है राउटर? What router will do? हेलो मिलेगी एग्जिस्टिंग नेबर से तो अपडेट भेज देगा. क्यों पैरामीटर चेक करेगा? नेबर तो बन चुका है, एग्जिस्टिंग नेबर है. अरे चुप रहो यार. क्या करेगा? टाइमर को रीसेट करेगा. What is the hello time in case of OSPF? 10 seconds. What is the hold time? 40 seconds. As soon as router will receive a hello, उसने एक बात फिर भी ठीक बोली थी, पैरामीटर चेक करेगा. पर बात मतलब की क्या थी? टाइमर को क्या कर लेगा? रीसेट. It will reset the. Now, if it is receiving a hello from a new neighbor, first thing, how he will get to know that it is receiving a hello from a new neighbor? Because as soon as he will receive a hello, there is no entry for that neighbor in its neighbor table. It means I am receiving a hello from a neighbor, but for that neighbor I am not having an entry in my neighbor table. So that state is called initialization. This thing is clear? Now what I will do, I will install his router ID in my neighbor table. So whenever I will receive the hello again, I must have his entry in my neighbor table. This thing is clear? When both the routers receiving hello from each other and have the entry of each other in their neighbor table, that state is called two-way. That a two-way connection has been established, we have exchanged our entries. And before this two-way states, how many things are checked in the hello? Which parameters are checked? Those parameters are, first is area ID. Second thing is subnet mask. Third thing is fourth thing is, पढ़ते हो आप घर जाके? OSPF पढ़ा है किसी ने? नहीं पढ़ा? EIGRP पढ़ा है? देख गया कितना पढ़ा है. एरिया आईडी, सबनेट मास्क, हेलो एंड होल्ड टाइम. There is nothing called hop count in case of OSPF. Anything that router must match during neighborship. कौन सी के वैल्यूज कहाँ जी रहे हो? कैसी एक्नॉलेजमेंट? एरिया आईडी, हेलो टाइम, होल्ड टाइम, सबनेट मास्क. हाँ बताओ. नहीं बता? मेरे को भी नहीं बताया. सो लोग और चीजें ठीक है. MTU तो अभी नहीं चेक होगा. अभी OSPF का पैकेट खोलूंगा फिर बता दूंगा, मुझे भी याद नहीं. सही में याद नहीं. अभी तुझे must be. Two routers with same router ID will never become neighbors. Two routers with same router ID will never become. Remember this thing. Next thing. Authentication. We will discuss this thing also in. We will discuss these two things also, but later on, not now. So the things you are concerned with: area ID, subnet mask, hello and hold time, router ID, authentication parameters. You must know these 5 points that must match on both the ends, except router ID, which must be unique. This thing is clear? So for becoming neighbors, routers will match these 5 things. If these 5 things will match, in which state they will come? In two-way state. In two-way state, two router will become neighbors. After becoming neighbors, now there comes a time when they have to exchange database. When they have to exchange the database. So what they will do? In X start state, what first thing will happen? Router will compare MTU of their interfaces, MTU of their, like we have example R1 and R2. R1 will always forward in X start state MTU of this interface, and R1 will also send MTU of this interface. This thing is clear? Now, if MTU is matched, only then there will be an election called master and slave. Now guys, what kind of packets are exchanged now after your two-way state? Packets are DBDs. DBDs are called database descriptors. Database. Now what is the use of this master and slave? Actually, these two guys have to exchange database. So they are just telling each other about the sequence number of database they will be going to exchange. वो एक दूसरे को बताएंगे कि हम किस sequence number का database आपस में share करेंगे. This thing is clear? Now, after this, what do you mean by master and what do you mean by slave? Master means a router with the highest router ID. Slave means a router with the lowest router ID. Two routers are becoming neighbors. One will be having highest router ID. Second will be having lowest router ID. So router with lowest router ID will send it database first. It means the router with lowest router ID will send a request to the router with highest router ID that give me your database in form of which message? In form of which message? No bro, this is a state. Exchange is a state. See, in Xstart state, there are actually two things. One is MTU check. Second is master and slave. Router with highest router ID will become master. Router with lowest router ID will become slave. Now router with lowest router ID will ask from router with the highest router ID, what is your sequence number? They will exchange each other's sequence number. Work is over. Now they will come in which state? Exchange state. Now slave will send a link state request. What it will send? That give me your database. Master will send a link state update that this is my. Now slave will send a link state acknowledgement. Okay, I got your database. But this process is only initialized by slave. But as soon as the master will get a link state request from the slave, it will send its link state request to the slave. इसका मतलब ये, मैं स्लेव हूं, मैंने अपने लिंक स्टेट रिक्वेस्ट किसको भेजी, मास्टर को, मेरे को सिर्फ इनिशियलाइज करना था प्रोसेस को, आई जस्ट हैव टू इनिशियलाइज द प्रोसेस, आई हैव इनिशियलाइज्ड इट, नाउ मास्टर क्या सेंड करेगा, बट मास्टर विल सेंड इट्स ओन लिंक स्टेट request, both of us will exchange the database. This thing is clear. After exchanging the database, we will load this database into our database table. After that, state will be full. Full means adjacency has formed. Adjacency has, what do you mean by this thing? Two routers have successfully exchanged database, guys. They become neighbor in which state? Two way. They were already neighbors, but now they have exchanged the database also. They have exchanged the database also. This thing is clear. After exchanging database, state will be full. Now, from this database table that router have exchanged, what they will run? They will run an algorithm called OSPF, shortest path to form the routing table, or indirectly you can say to calculate the shortest path to reach each network in the same domain. This thing is clear? Fine. Up to this point you have understanding, like, yes, in OSPF there will be something called area. In an area, every router will be having same database. What they will do, they will first of all, they will become neighbors, then they will exchange database, and after that, using that database, they will calculate shortest path to reach each and every other network that belongs to same area, and with the lowest cost. This thing is fine. Now we have to discuss how OSPF database looks like, or how OSPF will build the database. This thing is clear. Now, in case of OSPF, database is called LSAs. What we call them? Link state advertisements. Link state. Every router in the domain will generate information about itself. Every router in the domain has to generate information about, only then he will be able to exchange that information with the other routers. This thing is clear? So that self-generated information or information generated for self, जो router अपने लिए information generate करेगा उसको क्या बोलेंगे? क्या बोलेंगे? What do we call it? Type 1 LSA. What do we call it? Type 1 LSA. What do we call it? Type 1 LSA, or you can call it router LSA, router link state advertisement. Guys, if I say this is R1, how this router will represent it LSA? With the help of router ID. So its router ID is let's say 1.1.1.1. So its type 1 LSA is represented by 1.1.1.1. Who will advertise this LSA? This router will advertise this LSA. For advertising this LSA, this router will again use its router ID. So LSA ID and router ID will be same. मैं अपना एक डेटाबेस बना रहा हूं, मैं अपने डेटाबेस को कैसे रिप्रेजेंट करूंगा, अपनी राउटर आईडी से कर दिया। मैं जब उसको किसी और को दूंगा यही बता के दूंगा ना कौन दे रहा है, मैं, और एडवर्टाइजिंग राउटर भी कौन होगा, 1.1.1.1। इसका मतलब इट मींस इन केस ऑफ टाइप 1 LSA माय LSA ID एंड माय एडवर्टाइजिंग राउटर ID विल रिमेन सेम। ये बात समझ में आई? पक्का? मैं अपना डेटाबेस क्रिएट कर रहा हूं, मैं अपना डेटाबेस को नाम क्या दे रहा हूं, अपने राउटर आईडी, और दे कौन रहा है सामने वाले को, मैं दे रहा हूं। तो एडवर्टाइजिंग राउटर भी कौन है, मैं ही हूं। तो लिंक स्टेट आईडी और एडवर्टाइजिंग राउटर आईडी क्या रहेगी, सेम। नेक्स्ट थिंग दैट विल कम इनटू प्लेस, देयर विल बी अ सीक्वेंस नंबर विद एवरी डेटाबेस। This thing is clear, and there is, after that there is something called age. What is age? Age is represented in case of OSPF, database is flooded after every 30 minutes, or you can say 1800 seconds. See, let's come back to that point. What are full updates and what are partial updates? What are periodic updates and what are incremental updates? In case of OSPF, there will always be periodic updates. Periodic means after 30 seconds they will exchange database. Now, if there is a change, update will be incremental but never partial. It will always be full. EIGRP के केस में, हिंदी में बताता हूँ, EIGRP के केस में दो राउटर सिर्फ एक बार ही क्या एक्सचेंज करते थे, डेटाबेस, अपनी टोपोलॉजी टेबल एक्सचेंज कर ली। जब चेंज होगा तो कभी भी अपडेट फुल नहीं जाएगा, कैसा जाएगा, पार्शियल। जो चेंज हुआ वही मैं सामने वाले को बताऊंगा। लेकिन इन केस ऑफ OSPF व्हाट विल हैपन, दो राउटर है, पहली चीज दे विल एक्सचेंज पीरियोडिक अपडेट। सेकेंड थिंग, if there is a change there will be no partial update, there will be again full update। क्योंकि मैं डेटाबेस में चेंज नहीं बता सकता किसी को, मेरे को सारे का सारा डेटाबेस दोबारा देना पड़ेगा। दिस थिंग इज क्लियर, फाइन। क्योंकि यहां पे मैं रूट्स, आई एम नॉट एक्सचेंजिंग राउट्स हियर। इन केस ऑफ EIGRP आई वाज एक्सचेंजिंग, here I am exchanging through that database, router is forming the routing table. Now we will look for the thing how database looks like. Fine, clear? Age bro, time बताया ना, after every 30 minutes they will exchange the database again. This is a periodic update. So whenever I will receive the database, this time will start from move till after this database is flushed and the router will again send me the database. This thing is clear? Any problem? Now we have to discuss about type 1 LSA. भाई बताओ, मैं टाइप 1 LSA अभी पढ़ा दूं या CCNP में पढ़ाना है? पढ़ा दूं ना, अभी खत्म कर दूंगा मैं, अभी मैं दोबारा नहीं बताऊंगा फिर इसके बारे में। देखो यार, सच क्या है, मैं LSA दिखाऊंगा तो पूरा दिखाऊंगा, मैं कोई बात छुपाऊंगा नहीं। फिर यार इससे पूछो भाई, LSA में कुछ छुपाने का रह जाएगा? फिर अगर मेरे को चाहिए, मेरे को आधा घंटा चाहिए कि LSA समझाने के लिए, ऐसे ही मेरे पास 5 LSA हैं। इतनी इन्फॉर्मेशन बहुत है, फाइन। अब मैं आपको ऊपर ऊपर से बता देता हूँ एक्चुअली होगा क्या। फाइन, LSA दिखाऊंगा नहीं मैं, आपसे मैंने पूछ लिया क्योंकि आप खुद कह रहे हो भाई बहुत ज़्यादा हो जाएगा डाइजेस्ट करने के लिए। मैं तो बता दूंगा भाई, मुझे कोई प्रॉब्लम नहीं है, ठीक है भाई। तो LSA मैं आपको अंदर से नहीं दिखाऊंगा, मैंने आपको लिंक आईडी का मतलब बता दिया, LS आईडी का एडवर्टाइजिंग राउटर बता दिया, सीक्वेंस नंबर बता दिया क्या होगा, और एज बता दिया. नेक्स्ट थिंग, व्हाट इज द यूज ऑफ सीक्वेंस नंबर इन केस ऑफ OSPF? Guys, in case of OSPF, there is nothing like split horizon. There is nothing like. So to prevent update loops, we have a concept of sequence number. If on a multi-access segment, a router is receiving its own update back with the same sequence number, he will never accept it. He will never. This thing is clear. Now, what is the information in टाइप 1 LSA? टाइप 1 LSA में इंफॉर्मेशन क्या होगी? ध्यान से सुनना आप. पहली इंफॉर्मेशन, क्योंकि टाइप 1 पे ही कौन सा LSA डिपेंड करेगा? टाइप 2. आज दो ही डिस्कस करूंगा. फाइन, तो बहुत ध्यान से सुनना और क्वेश्चन पूछना. इन टाइप 1 LSA, राउटर विल बी हैविंग इंफॉर्मेशन ऑफ फर्स्ट इंफॉर्मेशन रीड द लाइन. अब इसका मतलब ये नहीं है जितने मर्जी नंबर ऑफ लिंक्स हो. इट डजंट मीन वट एवर नंबर ऑफ लिंक्स आर कनेक्टेड टू मी. आई एम टॉकिंग अबाउट द लिंक्स ऑन विच आई एम रनिंग OSPF. सो शिट सोचने की जरूरत नहीं है. दूसरी बात, second point is, what is the mask? Three things. Repeat the three things. Number of links, networks we are running on those links. Third thing. Fourth thing, cost on. Fifth thing, neighbor reachable from those links. Sixth thing, my interface IP address. So what are the 6 things? Repeat first of all. आपको क्या लगता है कभी मैंने ये चीजें याद की होंगी? नहीं यार, मेरे माइंड में है OSPF काम कैसे करता है. आप कोई और क्लास लगाना मेरी, मैं किसी और तरीके से OSPF पढ़ा रहा हूँ, क्योंकि माइंड में हमेशा चीज सेम नहीं रहती. तो मैंने चीजें याद नहीं की हुई, मुझे रिजल्ट याद है, मुझे आउटपुट याद है, मुझे LSA याद है, इस LSA में क्या क्या है, बस मैं उसी चीज को अपनी वर्डिंग्स में कन्वर्ट करके लिख देता हूं. तो देयर इज नो नीड टू रिमेंबर दीज थिंग्स. ट्राई टू अंडरस्टैंड कि OSPF काम कैसे कर रहा है. फाइन, आ जाओ अब देखते हैं, आगे चलते हैं थोड़ा सा. वेरी शॉर्ट एग्जांपल, R1 एंड R2. दिस इज नेटवर्क A, this is network B. So for R1, number of links will be 2. Fine. One is A, subnet mask will be /24, cost will be, let's say, 10. Second is B, /24, cost is, let's say, 10. Fourth thing, sorry. ये हो गया, ये हो गया, ये हो गया. नेबर रीचेबल फ्रॉम दोज लिंक्स. नो नेबर. एग्री on this link? Who is the neighbor? Let's say router ID is fine, visible. Okay, let me change the color. Neighbor reachable is fine. My interface IP addresses, let's say here we are running B2. My interface IP address B1. This will be the information in which LSA type. type 1 LSA. Router 2 will also build its type 1 LSA. First information will be number of links 1, network B slash cost is, let's say, 10, my interface IP address B2, neighbor reachable 1.1.1.1. Clear? This thing is clear? Now R1 will send its type 1 LSA to R2. Fine. R1 will represent this LSA with its router ID 1.1.1.1. R2 will represent its LSA with its router ID 2.2.2.2. पंखा चला रहे भाई, मेरे को बोल दिया अगर पंखा चलाना हो तो, कोई दिक्कत नहीं, फटाफट। किसी को ठंड लग रही हो तो ऐसी जगह बैठना जहाँ पंखा नहीं है। हाँ बिल्कुल यार, गर्लफ्रेंड का फोन आया, नींद नहीं आएगी उसको। हाँ भाई, now R1 will mark its LSA with the router ID and this LSA with the router ID. Fine. This thing is clear. कोई issue किसी को? In the end, after exchange of updates, how many LSAs R1 will be having? 2. How many LSAs R2 will be having? 2. Agree? Now R1 has to use, or we will discuss from the R2 point of view, R2 has to use this LSA and this LSA to build its routing table, to build its, भाई डेटाबेस एक्सचेंज हो चुका है, नेबर बन चुके हैं, अब क्या बनाना है राउटर को? राउटिंग टेबल. नाउ सी, R2 will say I am getting database from 1.1.1.1. So R2 will get to know 1.1.1 is my neighbor. On which interface this neighbor is there? On network B. It means on this interface. Agree? Any problem? It means this time R2 knows that on this interface a particular neighbor is connected. Now R2 will check R1's database. Which database? Network is B. I have information about this network. R2 will say yes, I already have information about this network. Agree? Now second network is A. R2 will say yes, this is a network I have to install in my routing table. So R2 will mark this network as O. O means OSPF, intra area. Now R2 will install this network in its routing table as OA/24. Now R2 will be in confusion because whenever I have to install a network in my routing table, I need one thing, that is called next hop. That is called. Now R2 will use this IP as his next hop. As is. Why? Because this is the interface IP forwarded by R1. This thing is clear. So R2 will mark. If I have to reach A/24, next hop will be. Next thing that left is cost to reach this particular network. This thing is clear. How R2 will calculate the cost. Now, very important thing. For R2, for B network cost is 10. This thing is clear. R1 is also forwarding the same cost. So this time cost is added. For A network cost is 10. For B network cost is 10 plus 10 is 20. But if R1 is forwarding the cost 100, will R2 prefer 100? No, never. Because cost is always added on the receiving interface. Cost is always added on the. R2 is receiving the update. R2 will always choose the cost in its own database. R2 will always choose the cost in its R2 हमेशा उसी कॉस्ट को ऐड करेगा राउटिंग टेबल में जो कॉस्ट उसके खुद के इंटरफेस की होगी। उसके खुद के इंटरफेस की कॉस्ट क्या है 10। अगर मैं यहां पे 100 कर दूंगा देन टोटल कॉस्ट विल बी 110। दिस थिंग इज क्लियर। तो व्हाट आई वाज सेइंग इज R2 विल ऑलवेज यूज इट्स metric in its own LSA, never metric that is forwarded by R1. This thing is clear? Fine. कोई इश्यू किसी को? तो राउटिंग टेबल राउटर कैसे बनाएगा समझ में आया? नेक्स्ट थिंग, दिस इज R1, दिस इज R2, दिस इज R3. फाइन. R1 will create its database, number of links. Fine. Number of links. 1. Networks. Neighbor reachable. Any issue? No. After that, cost 10. After that, A1. R2's database, number of links, networks, neighbor reachable, interface IP. Any problem? R3's database, number of links, network, neighbor reachable, interface IP, cost. In this case, cost is also 10, 10. R1 will represent its database with its own router ID 1.1.1. R2 will represent its database with its own router ID 2.2.2.2 and 3 will represent its database with its own router ID 3.3.3.3. As database is exchanged, R2 will give it database to R1, R2 will give R3 will give it to R2, R2 will give it to R1. R1 will be having how many databases? R2 will be having, R3 will be having 3. This thing is clear. Now R1 has to build its routing table. Fine. Now R1 will say that how many neighbors are reachable from me? Only 1. But always keep this thing in mind. On R1, R1 will be knowing also about 3.3.3.3. This thing is clear. Similar case with R3. R3 will also be knowing about, because it has received database with ID of 1.1.1.1. Now, when R1 has to build its routing table, R1 will say I have two databases, one of 2, one of 3, but only neighbor reachable to me is 2.2.2.2. It means to reach R3, my next hop will be A2, that is forwarded by R2. This thing is clear. So it will install the network. Which network? B network /24 with a cost of 10 in its routing table with the next hop of A2. This network is marked as O. O means OSPF intra area. OSPF intra area. This thing is clear. Now guys, in case of OSPF, we have something called network type. We have something called, what are network types? OSPF defines two types of network type for you people in CCNA only. One is, sorry, 3. One is, other one is loopback. Loop back we will discuss tomorrow. Today we will discuss about point to point and broadcast. See, on a serial media, this media is called point to point media. Just tell me, on this serial media, a router can have more than one neighbor. On this serial media, a router can have more than one neighbor. No, this thing is clear. But if I say this media is fast Ethernet, which is this media? I can have more than one neighbor on this media. So OSPF defines a network type called broadcast for which interfaces? And point to point for which interfaces? Serial. This thing is clear. Now, whenever R1 has to build its database in case of serial, number of neighbors reachable on this interface will always be 1. Agree? This thing is clear. But whenever we talk about broadcast media, number of neighbors reachable on this interface can be more than how? Here we can connect a switch, we can connect here. How many neighbors will be there on one single interface? 5. So whenever R2 has to create type 1 LSA, neighbor reachable on this particular interface will be, how many neighbors will be there? 5. Just think like on a multi-access segment, 100 routers are connected. So every router has to keep information of 99 routers present on the same segment. In which LSA? In type 1 LSA. Agree? Just to shorten my type 1 LSA, I have created which LSA? Type 2. What information will be kept in type 2 LSA? Type 2 LSA will be called network LSA. It will create it will be having the information of how many? How many? भाई कहाँ है ध्यान? How many routers are connected on this? Multi-access. In case of serial, this information was stored in type 1 LSA. But in case of broadcast media, if I store this information in type 1 LSA, type 1 LSA will be very long. Just to make my type 1 LSA small, I have built one more type of LSA that is called type 2 LSA. Type 2 LSA will keep the information of how many routers are connected on this multi-access. भाई इस पर्टिकुलर नेटवर्क पे स्विच से कितने राउटर्स कनेक्टेड हैं जो OSPF में पार्टिसिपेट कर रहे हैं. एग्री? एग्री? दिस थिंग इज क्लियर. व्हाट इज टाइप 2 LSA? व्हाट विल बी द इंफॉर्मेशन इन इट? क्लियर? नेक्स्ट पॉइंट. अब याद देखो, डू every router connected in this multi-access segment will create this LSA. अरे सुन तो लो, दिमाग तो लगा नहीं. Question is, do every router which is connected on this segment will create type 2 LSA? See, for all the routers, information in the type 2 LSA is same. Agree or not? Agree or not? Agree? See, if this router will create, this will also create, or I will say 100 routers will create the same information. They will exchange it also. It means the information I am generating, I am getting it from how many neighbors? 99 neighbors. This thing goes same with the other routers also. Agree? Just to limit this thing, just to limit the flooding of database, we have the concept of DR and BDR. समझ में आया DR और BDR क्यों आया? Why we have DR and BDR? This thing is clear. First of all, why we have type 2 LSA? First question. Why we have? In case of serial media, router is having an information in type 1 LSA, neighbor reachable from the particular link. If we are on a broadcast media, number of neighbors can be more than one. So type 1 LSA will be long. To shorten my type 1 LSA, I build a type 2 LSA. What information will be included in type 2 LSA? How many routers are connected on the multi-access segment? Now the question is, do every router in this multi-access segment will generate type 2 LSA? If every router will generate, what will happen? Every router will get the same information from 99 other routers which are connected in the same domain. Agree? Now, to resolve this problem, we have the concept of DR and first of all we will discuss the concept of DR. What is DR? Designated router. See, out of these 100 routers, they will select one router as father. One router as father. It means they will try to find a centralized point with which they will exchange database. They will never exchange database directly. This thing is clear? So what they will do, let me draw the diagram again. R1, 2, 3, 4, 5. Fine. 6. Out of these 6 routers, one router will become DR. Now every other router will never exchange database directly. They will just become neighbors. Neighbors means they will remain in which state? Two-way. And they will form adjacency with which router? DR. They will only exchange database with DR. They will only exchange database with, but they will remain in which state? Two-way. Now, I am DR. All are exchanging database with me. It means I am the one who is responsible for their communication. Agree or not? And you know, all other routers in the topology will never generate type 2 LSA. Who will generate type 2 LSA? Only DR. So I am the one who is generating type 2 LSA and giving it to all others. Fine. Fine. Second thing, every other router in the topology is forming adjacency only with me. Only with, so they will exchange database with me. I will pass on to other non-DR members. Other non-DR. See, हमारे पास प्रॉब्लम क्या थी? R1 स्विच, R2 R3. फर्स्ट केस में प्रॉब्लम क्या थी कि तीनों क्या एक्सचेंज करेंगे? तीनों क्या जनरेट करेंगे? टाइप 2. फाइन. बाय इलेक्टिंग DR, हु इज जनरेटिंग टाइप 2? ओनली R1. He is generating type 2, giving it to R2, also giving it to. What I am saying now, R2 and R3 will never exchange database directly. See, if R3 will give it its database to R1 and R1 will give that database to R2, how many copies of database R2 will be having? 1. But if R3 is giving database to R1, R1 will forward that database to. And if R3 again give it database to R2, how many copies of database R2 will be having? 2. So just to reduce flooding of database, we have the concept of DR. देखो दोबारा बोल रहा हूं, अगर R3 अपना डेटाबेस R1 को देगा और R1 किसको देगा? R2 को, तो R2 के पास कितनी कॉपी होंगी डेटाबेस की? 1. लेकिन अब R3 R1 को भी दे देगा, R3 R2 को भी दे देगा, तो R2 के पास कितनी कॉपी हो जाएंगी? 2. किसकी? Same database की. So just to reduce the flooding of, we have the concept of DR. So DR is having two functions. Every other router will form adjacency with DR. Second thing, it will generate type 2 LS. This thing is clear. Now, what is the use of BDR? Guys, if in this topology DR goes down, who will take the role of DR? BDR. तो जब तक जो बातें अब तक मैंने आपको बताई, the things we have discussed till now, are applicable for DR also and BDR also. It means type 2 LSA is generated by DR. Second thing, every other router in the topology will form adjacency with DR also and BDR also. And third type of routers which are not DR and not BDR are called DR other routers. Are called DR other routers. This thing is clear. Now how DR is elected, we will discuss it tomorrow. Tomorrow I will finish OSPF. I will finish routing. Day after tomorrow we will start with switching. IP वर्जन 6 का पार्ट है वो, ठीक है भाई. IP वर्जन 6 2 दिन लगेंगे खत्म करने में. DR का बैकअप है BDR. अगर DR डाउन जाएगा तो बैकअप में कौन है? BDR. ठीक है जी. इलेक्शन कैसे होता है कल देखेंगे. फाइन.